Hello everyone, it's really great to be invited to speak here today. And what I'm going to go through with you is a quick and brief look at what Ireland's climate looks like right now and how it's changed over the last number of years, but also how the climate projections view our future. So I'm going to go right back to basics because I'm conscious that not everyone in the room is a climate scientist, and when I say a certain thing, I kind of want everybody to be thinking that thing as well. So just a few little definitions. Weather. Weather is what we experience every day. So when we look out the window, when we look at the forecast, that's our weather. Climate is the average weather over an extended period of time. So we normally take that extended period of time to be about 30 years, and this is so that we can be sure what we're looking at is climate and not year-to-year variability. So climate is what we expect, but weather is what we get, and very often what we get is not what we expect, which is the issue with climate change. So climate change is the change in climate, or that average weather, over that period of time, and it's persistent. So to understand our climate, first we need to know what drives that climate. And the dominant influence on Ireland's climate is the Atlantic Ocean, in particular the AMOC, which we can see in this graphic from a Nature publication. And this is characterised by a northward flow of warm water, which includes our own Gulf Stream, and a downward flow in blue of cold water. And as a consequence of this, it means Ireland doesn't get any of the extreme temperatures that other countries at a similar latitude to us experiences, such as extreme heat and extreme cold. We also experience a range of air masses coming from that polar and Arctic regions, as well as the tropical, maritime and tropical continent regions. And this also helps give us our variable weather. So what do we expect Ireland's climate to be like? Well, normally we expect our warmest months to be July and August, our coldest months to be January and February, our wettest months to be December and January, and our driest months to be April and June. This isn't always the case, unfortunately. So when we look at what our climate currently looks like, we look over those 30-year time chunks. And we call these our climate normals. Now, last year, Met Éireann updated their climate normals to be the 1991 to 2020 period. And this shows us the current state of our climate. And when we want to look at how that current climate has changed, we compare this new set of climate normals to the previous 30-year climate normals. And Met Éireann has published a number of really nice pieces of information around these climate normals, such as the story map, which is playing in the background, but also there is kind of a summary report, and if you want to know any more information or detail about the slides I'm going to show next, please do follow those links and go in. So I'm just going to look at temperature and precipitation changes for right now. The first plot here shows the 1961 to 1990 temperatures. The second plot shows the 1991 to the 2020 annual mean temperatures. And this shows the difference. So this shows how our climate, or how our temperature, annual temperature, has changed between those 30-year time periods. And what we can see is that our annual temperature, it has increased. And it's increased by about 0.7 degrees. So while we're not warming at the rate that Europe is warming, we're still warming on an annual level. Now, this plot, I'm going to just highlight a few things. This dark black line is the average. So this is the trend we're looking at, and this is upward. So we can see that it's getting warmer. This zero line here, everything above it means the temperatures are warmer than we expect. Everything below it, blue or green, our temperatures are lower than we expect. And then what the bars represent is the kind of year-to-year variability. So you can see, though, even though the trend is warming and we're getting warmer, it doesn't mean we can't get a cold year in the middle. And this is what we mean by annual variability, that while we're still warming, there is the possibility of a cold year. If we look at what happens at a seasonal level, well, through spring, summer, autumn, winter, what we see is that we get an increasing temperature across all seasons. The greatest increase is in spring, the smallest increase is in winter. And when we look at other types of temperatures, such as maximum temperatures and minimum temperatures, we see these are increasing as well. Now, if we do the same kind of exercise for precipitation or rainfall, this is annual rainfall in millimetres. The first plot, again, is 1961 to 1990. The second plot is 1991 to 2020. And when you look at these side by side, it's hard to see if there's any real difference. They look quite similar. But when you look at the difference, you can see that Ireland, on annual, is getting wetter. Yay, what everybody wants to hear. And the rainfall is increasing by about 7%. And when we look at this chart again, same thing here. This black solid line is our rolling mean. Our zero line, so everything above this line means it's getting wetter, everything below this line means it's getting drier, and you can see again the annual variability represented by the bars. And you can see it's much more variable than temperature, isn't it, the rainfall? So you're much more likely to get kind of annual variability year to year. So, we have to be careful when we look at these trends. When we look at rainfall in terms of spring, summer, autumn, and winter, what we see is that there are net increases across all seasons, despite there being some spatial variation. So you can see, for example, in winter, here some parts of the country are drier, some parts of the country are wetter, but when you look across the country as a whole, it's getting wetter. The greatest increase in rainfall that we've seen in the last 30 years is in summertime. Hey, that's good for the next couple of months, isn't it? And the smallest increase in spring the smallest increase has been seen in spring. When we look at different types of rain, so we're looking at, say, rain days, which is rain with greater than 0.2 millimetres of rainfall, wet days, which is rainfall greater than 1 millimetres, and very wet days, which is rainfall greater than 10 millimetres. What we see is that these are all increasing annually as well across the country. And one thing to note is that Ireland is following the global trend when it comes to climate change. These are the temperature plots. I took this from the ECMWF. This top one here is the monthly global surface air temperatures. These are global, these are European, and you can see there's like a trend here. Everything is getting warmer and warmer. This is an old plot, which I need to update, but again, it kind of shows a similar picture for Ireland, where everything is getting warmer, and you see 2023 there is the warmest year yet. So when we look at climate change, so that's kind of our climate right now. So what's that going to look like in the future? How do we monitor what it's going to be like in the future? We don't have a crystal ball. So what we do is lots of countries and organizations around the world, they each develop their climate models, and they run the climate models. They take the what's happened in kind of the historical past. They also take the current state of the climate, and then they run various different iterations. And what you'll see here is each line in this plot represents an instance of a climate model or an outcome. And each line here all gives a possible potential future. So there's so much information in this plot. How can we use this information to make decisions? What does it mean to us? At the moment, it means very, very little. And that's because there's a lot of known and unknowns kind of built into this plot here. And it's very difficult for us to be certain of our outcome. And I'm going to take a little bit step back here, because we deal with probability and uncertainties every day in our lives. And I have an example which hopefully is relevant here. Will I hang my clothes outside to dry today? So what I've done is I've taken some Met Éireann forecasts and highlighted the rainfall probability for a few different outcomes to kind of show what we do when we kind of run climate models and how we deal with the uncertainty in them. So here we have a 0% chance of rainfall. I think I'm going to hang my clothes outside. Here we have 25 to 35% chance of rainfall. How do I deal with that? Me, I would probably chance it and hang my clothes outside. Others maybe might be more risk-averse and wouldn't. This, for example, 80% dark rain clouds here, definitely wouldn't hang my clothes outside. So even just based on that little amount of information, I am kind of dealing with probability and uncertainty in an everyday situation. Now, what about this one? 50% chance of probability. Oh, I haven't a clue. Will I? Won't I? I think I need a bit more information. So what I would do is I would look at what's happening before it, what's happening after it, and maybe add a little bit more information and look at a satellite image and go, are there clouds? Is there any systems? And in this instance, I probably would hang my clothes outside. However, in this instance, if it's this chance of rainfall before and this chance of rainfall after, I probably wouldn't. So you can see how even when it's difficult, when we're given that single probability, by having that extra information, it allows us to make a decision. And that's what we do when we look at the climate models. So with more information, we can narrow this spread of uncertainty. We can't completely remove it. We don't want to remove it. We want to know what the worst outcome, the best outcome, and that middle is. But we can definitely make it a little bit easier than this. So I'm going to start with some of the unknown unknowns first, the things we can't really do much about at the moment. And these are the tipping points. I'm sure you've heard loads about this in media and things. And I've just listed a few. These aren't, and this is an exhaustive list. So there's the glacial ice sheet melt, the dieback of the Amazon forest, and the AMOC, which is that ocean circulation current off the coast of Atlantic. Now, this is probably the most important one for Ireland. And we can't say at this moment what an AMOC collapse would do to the Irish climate. What we can say is that we're currently researching it, and hopefully we'll have some idea in the future. So the things maybe we can do stuff about, these known unknowns, and a lot of these come from the choices that we make ourselves. So I'm sure you've all heard of early action, mid-action, late action. So this is kind of the global response. Are we going to act early and aggressively, or is it going to be a bit later? So early action, we think the outcome lies around here. So you can remove this top band. Mid-action, we think the outcome relies around here somewhere, between RCP 4.5 and RCP 6. So again, you're removing all this up here and all this here. So you are narrowing the spread. And late action, again, we think lands us somewhere up around here. The length of time we're projecting out to as well will help. So if we're projecting out to 2100, again, the full spread is like this. But if we're looking at 2040 or 2060, again, the spread narrows slightly because it's closer to the here and now. Enhancing the models. I mean, there's a lot of model uncertainty. Trying to model the atmospheric processes is extremely complicated, extremely difficult, and takes a huge amount of computing power and data storage that we just don't have at the moment. So we need to make assumptions and compromises when we model things. So as kind of computers and data storage and things become kind of more effective and more efficient, it means we can do more complicated programming and science, which will again enhance this. And then kind of another obvious one is focusing on particular locations. So these are all global climate models, but some global climate models work better over different parts of the world. So we should only look at the global climate models that work best over Ireland, if we're looking at that local Irish context. So this is what we do in the Irish context. If we look at these global climate simulations first, this is an example of an image from the IPCC website. And again, you see Ireland up here. It's a tiny little dot. This doesn't really help us when it comes to understanding what's happening really in the Irish local context. It's too coarse for decision making. And again, if we look at all these models, there's just too much information for us. So what do? First, we choose the global models of relevance for Ireland. We look at which ones work best over us. Then we zoom in. So we do something called downscaling. So we go from that little blob of a dot there down to something which at least resembles Ireland, or even higher resolution than this. And we go from maybe having 1 or 2 pixels of information to having a really nice detailed plot. And then we check, do we need to correct it? So we compare the historical period of the models to what's happened in reality, to the observations, and we can apply a correction factor out into the future. And then we get something that looks like this, a lovely map of Ireland, but nice detail that hopefully is robust and scientific. And this is exactly what Translate has done. It's taken the global climate projections, it's taken both global and European projections. It's downscaled them over Ireland to 1.5 kilometres, which is extremely high resolution. It's bias corrected them with current observations, which means we can look at changing values as well as actual values. And it's standardized the data, so we now have one kind of set of climate projections for Ireland that everybody can work off of. There's lots of information on the Translate webpage, just follow the link here. All the plots I'm going to show you in the next couple of slides can be gotten from the EPA's Climate Ireland portal, which we're very proud to work with the EPA on this. It's a really great resource. You can also find information on the National Framework for Climate Services webpage, or you can email these addresses for any extra details going forward. So just have a look at Ireland's future climate. We'll start with temperature first because this is the easiest one. These are all across global warming levels. So global warming levels are what Ireland could look like if global average temperatures exceed a certain threshold. And in these cases, the thresholds set are 1.5 degrees, 2 degrees, 2.5 degrees, 3 degrees, and 4 degrees. Just to give you an idea of where we're currently at, the WMO said last year that in the next 5 years, it's likely that one of those years will exceed 1.5 degrees of global warming. So this is quite close to home at the moment. And then depending on the adaptation or the approach, the global policy approaches, we'll see where we land in these. This is the most extreme one. Hopefully it's somewhere around here. So the top is average summer temperature, the bottom is average winter temperature, and what you can see is temperatures are increasing as you progress up the global warming levels across the entire country. For summer, there's a kind of west to east increase as well. You can see the gradient more clearly at 4 degrees global warming. In the winter time, the increase happens mainly in the middle of the country. It's more intense, and the kind of coastline gets the lowest increase, which is to be expected. For precipitation, it's a little bit more complicated. If we start at winter, which is the simpler of the two, this is winter average precipitation change. Again, what we see is that rainfall is increasing during winter, and it increases as you progress through the global warming levels as well. There's some spatial variations, but I mean, it's increasing everywhere. For summer, it's much more complicated a picture for the climate models. So if we look at 2.5 degrees of global warming onwards, all our climate models trend towards a drier summer. And our ensemble has, I think it runs 12 climate models. So all of those 12 climate models are in that drier line. However, below 2.5 degrees of global warming, when we look at 1.5 degrees of global warming and 2 degrees of global warming, there's a high degree of variability. So we can't say if it's getting drier or if it's getting wetter, unfortunately. So this is all great, having kind of an idea of the average temperature and the average precipitation changes. But is this what people need in order to make decisions? So we work quite closely with state sectors, semi-state sectors, and local authorities. And we found that while it's good to give them an indication, what they really need are sector-specific information to input directly into their climate adaptation plans. So what we've done is we've created sector-specific indices from the underlying core variables from the Translate programme. And again, all these are up on Climate Ireland to look at and download. And I've just pulled out kind of a few to highlight here over the next couple of minutes. So what you see here is we have 1.5 degrees global warming, 2 degrees global warming, 4 degrees of global warming, and these are all changed the baseline. So this is change in growing season length. And what we can see is that across all global warming levels from 1.5 degrees to 4 degrees, the growing season length for Ireland is increasing. And this could have huge implications for Ireland. The growing season start. Again, if we look at 4 degrees of global warming, we see that the growing season is going to start earlier. 2 degrees, again, we see it's going to start earlier. 1.5 degrees, it's less pronounced, but it does start marginally earlier at 1.5 degrees as well. If we're looking at rain, because that's kind of relevant at the moment, this is very wet days. The It's not very clear in this, sorry. But if we look across all global climate warming levels, again, we see that it's very wet days are increasing across the year with kind of spatial variations. Most increases in all plots are kind of the west coast of Ireland. If we look at consecutive rain days, again, what we see here is there's an increase in annual consecutive rain days. So these are a list of the indicators we've created that are available on Climate Ireland. We're currently developing these ones, so we hope to have some of them done by the end of the summer and up on Climate Ireland by the end of the year. And then these are ones that we may or may not be able to do depending on time. So that was average temperature, or average temperature and average precipitation. But small changes in averages can mean big changes in extremes. So if we have a look at this plot, what we see is a shift in the average. And in this instance, it's going from, it's temperature going from cold to heat. And we can see that shifting the peak rightwards means these extreme temperatures are more likely. So when we focus on these kind of extreme temperatures, or in this case, maximum temperature, again, when we look at the global warming levels, we see that the maximum temperatures are increasing. And when we kind of drill down into this and look at things that might actually impact us, such as summer days, which is temperature above 25 degrees, number of heat waves, nights above 15 degrees, and the warmest maximum, we see across all global warming levels that these are increasing for Ireland. And this has huge impacts on, say, for example, the transport system above 25 degrees. Railway lines start to buckle, tarmac starts to melt. Nights above 15 degrees can be a health risk problem for people who can't, because you can't regulate your temperature basically. And more frequent heat waves, for example, means an increase in demand on water, could lead to more drought, increased demand on energy and healthcare services. So just briefly, because I've only got 2 minutes left, how do we work with stakeholders in order to understand what that kind of means for them? Well, what we've done here, and I think it was raised in the last presentation, is we've worked with sectors. So we don't do things in isolation anymore as climate scientists. What we do is we go to sectors and we work with them to understand what is the question that they need to know in order to understand their risk. And what we've done in Translate is we've come up with this risk framework, and this is a kind of a qualitative risk framework which allows you to get an indication of your risk. It's not in-depth view, but it gives you an idea if you need to do kind of future work. So this takes the hazard, which in this case is heat, extreme heat. This is for school closures based on extreme weather events, so looking at the changing risk. So we worked with the education sector to understand the changing risk of school closures based on extreme hazards. So the extreme hazard in this case was temperature. The exposure was looking at student enrollment rates. And then the vulnerability was looking at deprivation and looking at broadband connectivity. The school said this was a big exposure. And then we looked across I didn't highlight this. The first plot here is early action, this is mid-action, this is late action. And you can see the changing risk across the country. As you go through the action levels, the risk increases. Now, this is an example that could be applied to a number of sectors, but we just chose the school closures here. And it gives a really nice kind of first look at risk based on hazards. And it's a really nice example of how you can work together. You take external information from the education sector and their concerns, and you combine it with the climate data to get a feel for their risk. And I think because I'm running out, I'm going to skip the next one, fortunately, and say thank you very much.